trig unit circle, as it were. Let's do this one first. Sine x over cosine x. We know that's going to be equal to opposite over hypotenuse times adjacent over hypotenuse, or divided by. Flip and multiply, that gives me opposite over hypotenuse times hypotenuse over adjacent. Hypotenuse is canceled out. I get opposite over adjacent, which is, in fact, tangent. So tangent of x is equal to sine x over cosine x. I need that like I need nothing else in this chapter. So from one other identity.
We just got to remember that equals tan.
Yep, the rest of that is just a proof. We don't need that. We know how to, proof's good. Happy. What else do I need to know? Mr. Manship, I said there's one thing you need to know about cosecant. I hope you know it. What is it?
Yeah, that it equals, I remember it, but I don't have the words.
You don't have the words for it?
I don't know how to say it.
You don't know how to say it. He's fishing for an answer. Blaine's trying to help him out. One? What?
Isn't it one?
It's one? You got to read the rest of it. He's going to give you the rest of it. There you go. What are the sign? What are the sign?
To the thing.
No.
X.
Yeah.
Yeah, same thing.
Okay, you got to have that in the list of tricks you know and memorized and have permanently in your logic, your memory. Remember, cos goes non-cos. This is cosecant, so it goes with the one that doesn't have a co on it, sine. Secant x. Mr. Sussman, what's secant x?
It's going to be 1 over cosine.
1 over cosine x. I love it. Next up, I have cotangent x. Gathiel. 1 over tangent x, which, by the way, would be equal to what? Using our earlier tangent one. That'll be the bottom. So when I flip that, so it becomes cosine x over sine x. Very handy road. We need all of those. We're going to use those often. Often. Now to the next two rows, which we're going to use very seldomly. I would, if you have not yet memorized its tangent sine over cosine, or what cosecant, secant, and cotangent is, now's the time to do it. If you're digging through your papers every time you run into one of those, you're going to be spending a lot of time digging through papers. All right, let's do the sine of x plus 360n. What the doodles? Mr. Combs.
Yeah.
What's that equal to?
No idea.
No idea. Okay, let's talk. What's n referred to in this case?
I have no idea.
It's a variable, right?
Yeah.
It's that, right?
Yeah.
And in the case it's an n, it's natural numbers, like 1, 2, -1, -2, right?
Yeah.
What if I had 360 to the angle that you start with? Let's say this was sine of 15.
Should I get my calculator out?
No.
Oh.
And I add 360 to it. What's going to happen?
It's going to be sine of 375.
Which would be the same as sine one trip around, right? Can't we subtract 360 each time?
Yeah.
So if I subtract 360, what do I end up with?
Wait, what am I subtracting 360 from?
From this. You said 375.
Oh, -15.
Not -15.
15.
15.
Same thing.
So sine 15, start with. What if I did 720, man? 2 times 360.
Still the same thing.
Same thing. What if I did, doing it in my head, 1080?
Same thing.
Same thing. What if I did -360?
Negative same thing.
No. Just add 360. You can add or subtract 360. It's the same thing, right?
Yeah.
So sine of parentheses x plus 360n is just sine of x. Bien?
What's that n there for then?
The n is I can do any number I want to. I could do sine of x plus 3,600 because 360 times 10. That make sense?
Yeah.
All right.
Where's me?
Yes, sir.
Should we put degrees next to that on the sheet so we remember it's not radians?
Yeah, sure if you like. Although there's a radian version of that, isn't there?
Yeah, it would be 2 pi n.
2 pi n. So if you want to put that next to it, that's fine too. All right, what about cosine? X plus 360 and Mirzayan.
It's just cosine x.
Just cosine x. Getting bored? Yes.
Are you recording it?
Yes. 5 minutes and 43 seconds. You just wanted that in there so she, when she hears it, she goes, "You have her back."
Maybe.
Just trying to get some friend credit. Is there a problem between you two we should discuss later? No? Okay, you're fine? All right, fine. All right. Now she's playing soccer, so. Don't know if she's going to be able to handle trig and soccer at the same time. I'm kidding. I gave you this answer. Let's see if you can figure out why this is true. And to do that, I'm going to let Miss Manship handle this one. How could this be true? How could sine of a negative sine of, oh, is there a minus sign in front of that?
Mm-hmm.
There better be, because otherwise this isn't true. Okay, good. So how could this be true? What is it? What are we talking about here?
Wait, what?
Yeah. Sine of negative some angle is equal to negative sine the angle itself. Let's take a for instance, shall we? This is what do you want, 30 degrees? This would be negative 30 degrees, right?
Yeah.
Sine of this would be what?
2 root 2? I don't know that thing.
Okay, you have to have it memorized by now. We're going to make her look. Perp walk all the way to looking it up.
Which page is it on?
It's chapter 3 or way back when, 4 maybe. 4-1. It's a big circly looking thing.
1/2.
1/2. It's good deal. You're giving everybody the answers. Is that your role?
That was all my brain.
Okay, that's okay. So you're looking for something to memorize something. It's okay. So this would be 1/2. Agreed?
Yeah.
So sine of 30 is 1/2. What's sine of negative 30? Don't help her.
-1/2.
Negative 1/2. Why is it negative 1/2?
Because it's -30.
Because it's negative 30, and that's not a great reason.
because it's in the...
All sad tigers cry. This is the negative side, right? So this is the negative side, therefore sine's negative there. So sine of negative 30 degrees would be negative 1/2, would it not? Because in the fourth quadrant. Negative sine of 30 degrees would be also 1/2, so it ends up being negative 1/2. And that's true, by the way, if you go to this quadrant, doesn't matter, right? Same angle, same angle. This is negative, that's positive, works. Even if you go past that point, this suddenly becomes negative, this suddenly becomes positive. Who cares? They switch, doesn't matter, same thing as solved. Are we good? Questions? All right. And again, I wouldn't spend a massive amount of time worrying about that one or the next one here. They're not ones. Here's one that's funky, though. Grolick,
Yeah.
you got this one. Let's make sense of it.
Okay. Let's draw the graph.
Let's do 60 degrees because it's a half. We don't have to do root 3 of 2.
Remember 60.
Ah! It's 1/2, right?
Yes.
Because otherwise, Gathiel's going to have to shout it all the way over there. It's a half, right? Gathiel, right? You're checking my work on memorization things I asked you to memorize? That's okay, fair enough. Okay, so it's a half. So how can this be true?
Because it makes the other side -1/2.
It does not.
-60.
Negative 60 degrees. What's cosine of negative 60?
1/2.
Just 1/2, right? Not negative at all because it's in the fourth quadrant. All sad tigers cry. That's positive, right? So this ends up being positive 1/2. And then cosine of 60 is also positive 1/2. So frequently enough, cosine of the negative of an angle is the same as cosine of the angle itself. Yes, sir?
If we get this on a test, it would be on the known calculator part.
Absolutely.
Okay.
Or calculator, probably wouldn't help you much.
Wouldn't we just be able to plug in cosine -60?
This is just the beginning of a fun chapter of fun. Trust me when I say that this will be the least of your concerns. That's why I said I don't get these four identities. I mean, they're something you should look at occasionally, but you're not going to be. This isn't the bulk of the chapter. Yeah.
So, what if the angle's like not in that fourth quadrant as well?
Oh, what if it's over here? What's cosine of 120 degrees? What if it's in the second quadrant where it's negative, right? It's going to be -1/2. And what's cosine of -120? Same rough angle, 1/2, same quadrant, so therefore it's also negative.
Okay.
Yeah. Weird, huh? We can do magic with trig. That's kind of actually the most important part of this thing. Now, the next identity is the one that if you do not memorize this identity, everybody's going to be looking at you strangely. You're gonna be that weird kid walking down the street that doesn't know how to do what sine squared plus cosine squared is.
Yeah, totally.
Totally, yeah. So, let's first come up with the identity. Sine squared theta plus cosine squared theta equals what? Well, sine is what? What size, Mr. Manship?
Sine is cosecant x.
Oh. If you're talking about a right triangle, what size of the triangle are you talking about with sine?
Wait. Opposite and a hypotenuse.
I love it. Opposite over hypotenuse, both of those squared, right? Because it's squared.
Yeah.
Plus, what's cosine?
Adjacent over hypotenuse.
Adjacent squared over hypotenuse squared. Agreed?
Yep.
All right. So what does that obviously equal?
That equals opposite squared plus adjacent squared over hypotenuse squared.
I love it. What does that obviously equal? I'll give you a hint. That's a 90-degree triangle. That's because we're using trig identities. Yep.
One.
What? Why is it 1? Because the guy next to you whispered 1?
No. I was converted.
Come on, Mr. Manship, you got a good brain over there. This is the opposite, right?
This is the hard chapter.
This is the adjacent. We're on page 2. It's too early for the chapter to be really hard. Look, this is the opposite side.
I didn't sleep all that night.
Focus. Focus. Opposite side, adjacent side. How are the opposite, adjacent, and hypotenuse arranged, according to Pythagoras?
Well, the hypotenuse is always longer.
That's true.
Like the.
By what ratio? How do we know how much longer?
Like the Pythagorean theorem.
Which would be? In this case?
It's like opposite squared plus adjacent squared equals square root of hypotenuse.
No, just hypotenuse squared, right?
Oh, yeah.
So, the opposite squared plus adjacent squared is equal to hypotenuse squared, right?
Yep. Wait, what's up top of that?
Hypotenuse, right? You said opposite squared plus adjacent squared. That's your hypotenuse squared. I agree with you.
Oh.
And hypotenuse squared or hypotenuse squared happens to be 1. So, everybody must chant on the way home. Or if you're at home, you must walk around the house. The sine squared plus cosine squared is 1. Trust me when I say there's going to be times that's going to save your life. Because you get some big old messy thing, and wouldn't it be nice to get rid of a sine squared plus a cosine squared?
Is it just always going to be 1?
It's always 1. It has to be 1.
All right.
By definition.
I got you.
Yeah. It's cool. So, good?
Yep.
All right. With that in mind, go ahead and try problem number 1, which means simplify that expression. Go ahead and do it.